Away we go. So the other day we looked at graphs of sine and cosine. We looked at, for example, y is equal to 3 cosine of 4x. That's what we looked at the other day. And we said we had to identify a couple important aspects of that graph. And one thing we had to identify was the amplitude. Does anybody remember as we looked at this graph, do you remember what we said the amplitude was? So it's the absolute value of the number in front. So 3. And then period, we had a way to compute the period. We took 2 pi and we divided it by, remember? Divided it by the number in front of x. And 2 pi divided by 4 gave us pi over 2. And so those were 2 important characteristics. Today what we want to do is we want to do other transformations. Okay? So to bring this back to something that should hopefully be helpful to you, if you had y is equal to x squared and y is equal to negative x minus 3 y squared plus 1, you would recognize that these graphs are similar. We would say this is the parent function, whereas this graph over here has transformations. And we described those transformations as 3 to the right. We described it as up 1 unit, and we described it with a vertical reflection. So when we graphed that, we went right 3, up 1, and we flipped it upside down. So that's what we wanted to do today with our sine graphs. And the good news is that it works out pretty well. The amplitude stays the same. It's just the absolute value of the number in front. Please, when you get to the test, do not write a negative value for the amplitude. When it comes to the period, we continue to take 2 pi and we divide it by b. So those stay the same. If you look at these equations, y equals a sine of bx minus c plus d, and y equals a cosine of bx minus c plus d, in either situation, this number on the end ends up being the vertical shift. So far, everything's pretty straightforward. The horizontal shift is what makes it challenging for some people. And the horizontal shift, we have to take the inside, bx minus c. We set it equal to 0 when we solve. And when we solve that, that calculates for us our horizontal shift. Our horizontal shift. Taught this many years, and I think by far and away the best way for people to carry out these operations is to always start with the vertical shift first. So I showed you on Wednesday last week that we start with the amplitude and the period. I would start with the vertical shift now, and then the amplitude period, and then we move to the horizontal shift. And if you take it in those steps, I think it should go quite well. So we are going to start with this graph right there. Wait a minute here. Okay, good. Excellent. All right. I couldn't remember if I put those other 2 examples on there. If there's a number being added or subtracted on the end, then there's a vertical shift. Can somebody tell me what the vertical shift is? Just 2. So what we're going to do is we are going to move the graph 2 units up at this time. I like to draw a dashed line to show that it's all shifted up 2 units. Can somebody tell me what the amplitude is? 3. So if I'm at a height of 2, and from there I go up 3, what will that bring my new height to? 5. The maximum height of this graph is 5. Because from 2, I go up 3 units. Also from 2, I go down 3 units. If I go down 3 units, what's going to be the lowest spot of the graph? -1. This now gives me the vertical structure of my graph. I can see the middle, I can see the top, or the maximum, and I can see the bottom, or the minimum. The period, I take 2 pi, and I divide it by b. b is the value in front of x. So if I divide by 1, I just get 2 pi. Let's mark it off, 2 pi. Cut it in half, I get pi. Cut that in half, I get pi over 2. 3 pi over 2, -2 pi, negative pi, -3 pi over 2, negative pi over 2. When you consider the horizontal shift, you look for, is there anything in the middle on the inside here? And as you can see here, there's all we have is just the x, okay? The 2 is on the outside. So there's nothing being added or subtracted on the inside like that. So there is no horizontal shift. There's nothing for a horizontal shift. Okay, cosine. Do you remember? Does cosine start at the top, bottom, or the middle? Do you remember? Cosine starts at the top or the bottom. Sine starts at the middle. So cosine is going to start top or bottom. Because it's +3, it will start at the top. So if we start at the top, where does the graph have to go from there? It has to go down, so it crosses over the middle. And then it will go to the bottom. And then it will come back up. And we continue with that constant pattern. Max, middle, min, middle, max, middle, min, middle, max. You go back and forth between the max and the min, crossing over the middle in between. So I'll cross over the middle, and I'll go to the minimum. Cross over the middle, go to the maximum. And now you can practice drawing your sine wave or your cosine wave and see how nice it looks. If we have a really nice graph they want to like show, you want to take a picture of? Nope? Okay. Sometimes people get upset with me when I grade the test. Not very often, but every once in a while. The graph is supposed to look like that. I have had times where people's graphs look like that. And they say, well, you're just counting points off because I have sloppy handwriting. Like, I can't help that I have sloppy handwriting. Can everybody agree that that can be helped? Like, that's not sloppy handwriting. That's called lazy and I don't care, and I'm going to cause an issue with you. So you do that to me, and I just take out the red pen and start making marks. Spend a little bit more time than that. Doesn't have to look, quite that perfect, but don't give me that red one, okay? All right. We move along. Sine graph. Vertical shift, amplitude, period, horizontal shift. Notice there's nothing being added on the end here. So there's no vertical shift. So it just stays right along the x-axis. Can somebody tell me what the amplitude is? It is 1. It's the absolute value of this number in front. The period, I take 2 pi, and I don't divide it by pi over 4. I divide it by the number in front of x, which is just 1, right? And 2 pi divided by 1 is 2 pi. Mark off 2 pi. Divide it in half to get pi. Half again to get pi over 2. This will be 3 pi over 2. What's different about this graph from the ones we've graphed in previous assignments is this graph does have a vertical shift. I'm sorry, a horizontal shift. Don't graph the horizontal shift right away. First, make what I call a ghost graph. Does sign start at the max, min, or middle? Starts at the middle. And start by heading up. I'm just going to put some dots in place. And just make this little dash right here. Okay, this is not my actual graph. This is the graph before the horizontal shift. Okay, a lot of people really struggle with the horizontal shift. So I'm going to make that ghost graph and then apply the horizontal shift. How do I tell the horizontal shift? You take the inside and set it equal to 0. Notice when you solve, you get x is equal to pi over 4. How does pi over 4 compare to pi over 2? Is pi over 4 more than pi over 2, or is it less than pi over 2? It's less, right? Everybody agree that pi over 4 is half of pi over 2? So that means that you're going to want to take each one of these dots and move it right half of a tick mark. So I take that and move each one over a half of a tick mark. If you don't make a ghost graph on your test, it's okay. Just make sure that I can read your graph really well. The ghost graph really shows me an indication that you're trying to communicate with me what to do. And hopefully you can see that the black graph is the same as the red graph. It's just shifted a little bit. I make a motion at this time that we do 2 problems from your assignment to cut down the amount of work you have. How's it sound? Thank you. Take out your worksheets. Let's go to the first 2 problems. Wait for this to load. There it goes. And here we are. We will do this problem and this problem together to take 2 of them off your assignment. Please tell me what the vertical shift is. 1. Amplitude. 2. Vertical shift of 1, amplitude of 2. I can draw that vertical representation of the graph. I'm going to go up 1 tick mark. Like that. If my amplitude is 2, what's the highest spot that the graph gets to? 3. What will be the lowest spot that the graph goes? -1. So it goes all the way up to 3. It goes down to -1. I now have the vertical structure complete. Okay? You get some points on the test just by doing that. Okay? Then what we want to do is we want to look at our period and horizontal shift. What is the period? Oh, no, I'll find you here. Yeah, it's right here. These are your assignments. So you take your 2 pi and you divide it by 1 and you get 2 pi. So I'll mark that out. 2 pi, pi, pi over 2, 3 pi over 2. -2 pi, negative pi, negative pi over 2, negative 3 pi over 2. By looking at it, can you tell me what the horizontal shift is? Pi over 4. If we were to take this thing and solve it equal to 0, you're right, we get pi over 4. I'm not going to do the horizontal shift right away. I'm first going to sketch a ghost graph. Then I will move things. This is a sine graph. Does sine start at the max, the min, or the middle? Starts at the middle. So I'm going to start in the middle, and I start by going up. I then cross back over the middle. I then go down to the bottom, and then back up. You told me that the horizontal shift was pi over 4. How much does pi over 4 compare to 1 tick mark? It's half of a tick mark. So I'm going to take each of these and move them half of a tick mark to the right. If it was negative, I would move it half of a tick mark to the left. Do our last one. This is by far the most challenging problem that you'll see, okay? If you can do this problem we just did and this one, you are game. You are ready to get an A+ on this next test. Okay? Vertical shift. Down 2 units. Because of that. So I move down 2. Amplitude. 2. Amplitude is always positive. Can anybody tell me the highest point of the graph? 0. If I'm at -2 and I go up 2 from there, that'll bring me to 0. What would then be the lowest part of the graph? -4. See, you guys are getting this. The vertical structure is taken care of. I now move to the horizontal structure. The period, I take 2 pi and divide it by 3. 2 pi divided by 3 does not simplify. Okay, just 2 pi over 3. I will mark 2 pi over 3. Now we're going to do something where people get a little bit confused. We're going to take 2 pi over 3 and we're going to divide it in half, or multiply by a half. If you take 2 pi over 3 and multiply it by a half, can you see what you get? 2 pi over 6, or pi over 3. Okay, good. No, that's fine. Oh, sorry. Does it make sense to everybody that if you took 2 pi divided by 3 and divide it in half, you get 1 pi divided by 3? Okay, so now let's take pi over 3 and divide that in half. Pi over 3 times a half. Pi over 6, thank you. Everybody wonders about the third tick mark. The third tick mark is always 3 times the first tick mark. 3 pi over 6 is the same as pi over 2. Good. There you go. Got those 4 laid out. There is a horizontal shift. I don't want to focus on it right now. I want to focus on getting my ghost graph down, then I'll do the horizontal shift. Where is the cosine graph going to start? Max, min, or middle? Min. Cosine starts at the max or min. Because it's negative, it's going to start down at the minimum. So it starts at -4. It goes to the middle. It goes to the top. Middle, bottom. The last thing we do is we determine the horizontal shift. To find the horizontal shift, we take 3x plus pi, we set it equal to 0, and we solve. 3x is equal to -pi. Divide by 3. X equals -pi divided by 3. How does pi over 3 compare to one of the tick marks? How many tick marks is pi over 3? 2. So I move it 2 tick marks. Every dot, I move 2 tick marks to the right or the left. To the left, because it's negative. So 2 tick marks to the left. So this guy right here moves back here. This guy right here moves back here. This guy moves here. And, you don't have to actually start moving every one so much as once you move a few, then just continue on with the pattern. There you have it. Sometimes people don't think that the graphs are very accurate. You don't get to do this on the test. You need to show your work, but I will show you the graphing option here. Ooh. You can go if you want. Or if you quick want to watch me press graph, there it is. I think it's a really accurate graph. I think it's pretty close. So you guys have a good one. Okay, you're now ready to complete those first 2 worksheets. I'm here at 1:15. See me if you need to. We'll see you guys later.